Alright, continuing Chapter 8 today, we're going to be talking about triangles. This is Chapter 8, Lesson 4. A quick, very much review warm-up for you. Copy down each of the problems, press play when you're ready to correct. Right, so x equals 81, 79, 81, and 36. Quite a bit of vocabulary today. We'll be going over each of these throughout the lesson. So here, this is a triangle sum theorem. So imagine if you had just cut out that triangle, and this works for any triangle, and you tear off two of the corners and put them up with the last corner, the third corner. It should give you a straight line. So this will show that for any triangle, no matter how obtuse, how scaling, how whatever it is, any triangle, we add those three angles together and we'll get a straight line 180 degrees, which means that the sum of the angles of any triangle will equal 130 degrees. Sorry, 180 degrees. So if we draw a triangle and extend one side, and then draw a line parallel to the extended side as shown, two sides of the triangle are transversals to the parallel lines. So just like the last lesson. Okay, so if we take those angles out and put them in the top there, we know that that will make a straight line 180 degrees. So three angles in a triangle can be arranged to form a straight line or 180 degrees. And here's the triangle sum theorem. So the measure of angles of a triangle in a plane add to 180 degrees. And just a couple of examples to explain that. An acute triangle has three acute angles. Remember, acute angles are less than 90 degrees. A right triangle has one right angle, one 90-degree angle, and an obtuse triangle has one obtuse angle, one angle larger than 90 degrees. So we want to find, measure angle P in this acute triangle. So we know that all three angles will add up to 180 degrees. So we'll substitute in the two angles that we know, 73 and 44. Add that to the unknown angle, and that will give us a sum of 180 degrees. And then we'll just solve for P. You want to get P alone. And so we're going to subtract 117 for both sides. And P equals 63. This means that the measure of angle P is 63 degrees. Okay, same for this one. This time we're finding the M in this obtuse triangle. Even though it doesn't look very obtuse. So using the triangle sum theorem, 23 plus 62 plus the unknown angle going to give us 180 degrees. Subtract 85 from both sides, and we have a 95-degree angle. So this means the measure of angle M is 95 degrees. Okay, an equilateral triangle has three congruent sides and three congruent angles. An isosceles triangle has at least two congruent sides and two congruent angles. A scalene triangle has no congruent sides and no congruent angles. So find the angle measures in the isosceles triangle. So using the triangle sum theorem, we know that two of the unknown angles are the same. We know that because this is isosceles and they're both named t, which means we can assume those are the two that are the equal measure. So we're going to take 62 plus t equals 180, or 62 plus 2t equals 180. Subtract and then divide. So this means that the angle measure t will be 59 degrees. So we have 62, 59, and 59. Alright, find the angle measures in the scalene triangle. So we have the same unknown. We're looking for the variable x. We know that using the triangle sum theorem, we'll add all three together. We should get 180 degrees. We'll combine like terms and then divide by 10. So x equals 18 degrees. We're not done here. Now we need to take that 18 and substitute it in for each of the angles so that we can find the actual measurement. So 2 times 18 gives us 36 for the top angle, 36 degrees. 3 times 18 gives us 54 for the bottom left. And 5 times 18 gives us 90. I'm sorry, that one's for the top one. So our measures are 36, 54, and 90 degrees. Okay, a similar example again, using the triangle sum theorem. We'll add all three together to equal 180 degrees. We'll combine like terms and divide. So x equals 9. We'll use that 9 and substitute it into each of the angles. 10 times 9, 3 times 9, and 7 times 9. To get 27 degrees, 63 degrees, and 90 degrees. The second angle in a triangle is 6 times as large as the first. The third angle is half as large as the second. Find the angle measures and draw a possible figure. Okay, so we're going to let x equal the first angle measure. And then 6x will be the second angle measure because it says 6 times as large as the first. And then for the third angle is half as large as the second. So we'll have 1/2 times 6x. And it'll give us a third angle measure. We're going to take those and use the triangle sum theorem. Add these three together. X plus 6x plus half of 6x, which is 3x, equals 180 degrees. Combine like terms and divide. So x equals 18. This means that the first angle is 18. And then we'll use that to figure out the next two angles. 6 times 18 is 108, and 3 times 18 is 54. So we have 18, 108, and 54. Okay, and you don't have to draw an exact angle. You don't need to use a protractor, but just sketch it out. You want to make sure that it has that obtuse angle in there that looks like it's larger than 90 degrees. We're going to go ahead and skip this one. So the midpoint of a segment is the point that divides the segment into two congruent segments. An altitude of a triangle is a perpendicular segment from a vertex of the triangle to the line containing the opposite side. An altitude is always perpendicular, so you know that it's 90 degrees there. And this helps us figure out the height of the triangle if it's not a 90 degree or a right angle. Okay, so here's the altitude here. The altitude goes from S to T. So in the figure, T is the midpoint. So T is the midpoint. That means that UT and TV are congruent. So we're going to find the length of ST. So we know that this segment is congruent to this segment. And we know that 26 is SU. So we're trying to find out ST here, this unknown side. So T is the midpoint of UV. That means we'll take this measurement of 20 feet and we'll divide it in two, and that will give us UT and TV. And that means that it is 10 feet. And then we're going to use the Pythagorean theorem since this half of the triangle is a right angle. A squared plus B squared equals C squared. So substitute 10 for B and 26 for C. And we'll be solving for A. And the square root of 576 is 24. So that means the length of ST is 24 feet, or ST is 24 feet. Okay, similar problem. This whole distance is 14 inches. We know that B is the midpoint of CD. That means that CB is congruent to BD. And we'll find half of that 14. We get 7 inches. So CB is 7 inches. BD is 7 inches. And again, we're going to use the Pythagorean theorem using 25 inches for C, 7 inches, and we're looking for this last side. So A squared plus B squared equals C squared. We'll use 7 and 25 and subtract, and we'll need to find the square root again of 576, which is again 24. So the length of AB is 24. Again, just sketch out the diagrams on your paper, answer the questions, and then press play when you're ready for part 2. Right here is part 2. Make sure that you sketch the drawing, and we'll be going over these in class.